So rigid body kinematics is when size and shape matter. So often the particle approximation is not sufficient. Examples of this are if drag is present. So if we account for wind resistance or something is moving through a fluid, the size of the object is definitely going to matter there. So is the shape. Also, if there's inertia. Most objects have inertia, so we can't always treat it as just a little dot, because sometimes it'll matter if it is a box or a wheel or a long skinny rod. All of those things are going to have an effect on how it behaves. Now, rigid body is a stiff object with mass and shape. So a rigid body does not change shape because it's rigid. Example is a rod or a wheel or a block. Example of something that is not a rigid body is a pillow, because a pillow can change shape. So anything that's hard, stiff, rigid body. So this has infinite elasticity modulus, infinite hardness, not squishy or deformable, and the distance between 2 points on the body is always constant. So example of this is, say you have a baseball bat. And the handle of the bat, we'll call that H. The tip of the bat, we'll call that T. Now, the distance between H and T is always constant, no matter what position the bat is in. So that's an example of how a bat is a rigid body. H and T are always going to be however long the bat is, the distance L. They're always going to be that far apart, whether the bat is horizontal, vertical, poking in or out of the screen, or swinging in a circle. Now, there are different types of rigid body motion. What we've learned for the particle was translation. Rigid bodies can translate. This translation can be rectilinear, which is straight line. So translation moves forwards, backwards. Rectilinear is in a straight line, and then curvilinear, curve. But the object always keeps the same orientation in curvilinear translation. So I will show y'all an example of that. So an example here of rectilinear translation, moving in a straight line. An example of curvilinear translation, orientation doesn't change, although the object does not move in a straight line anymore. So this is curvilinear translation. You can see the phone stays horizontal, but it's not moving in a straight line. So that's curvilinear translation. Also, we can have fixed axis rotation. So this is an axis, something could rotate around the axis. So example of this, say I have the water bottle. If I turn it like this, I want it to rotate around this fixed axis of my finger. It rotates like that. So that's a fixed axis rotation. Also, I could say we want it to rotate around the cap. So it's rotating around a fixed axis where my fingers are pinched. And then finally, general planar motion. General planar motion is when there's a combination of translation and rotation. So we'll see an example of that. All right, so here we had translation. We have fixed axis rotation. And then we can have general planar motion. So it's rotating and it's translating. Now, curvilinear translation, it stayed horizontal the whole time. Orientation didn't change. General planar motion, orientation does change. Now it's still in 2 dimensions, right? So that's general planar because it's in a 2D plane. Now, if I moved it forward and backward, that would not be general planar anymore because it has a 3rd direction. But here, all in the same plane, general planar motion.